2.3 functions. So another pretty short section overall, and again, pretty easy overall. But the first ones give us a set of points, and they want to know if the relation defines a function. So essentially they give us a bunch of points, and we want to know if it's a function, which means no x values can be repeated. And there's a couple different ways that we can show that. I'll show it probably with a mapping diagram because it's the easiest one to see overall without a lot of extra effort. But we'll start with 12. So they write it as like in a set. If you didn't put that, that's fine. Like the Algebra 2 book doesn't write it this way, but you do the exact same thing. So 8, 0, 5, 7, 9, 3, 3, 8. So those are the 4 points. So like I said, I like a mapping diagram, which is where we do the input, which are the x values, and the output. And depending on what I'm doing, I usually will line them up in order, but for the purpose of just this, I'm just going to write them like with their pairs. So 8 and 0, 5 and 7, 9 and 3, and then 3 and 8. Now, if anything is repeated, x or y, we only write it one time. But that goes with that, that goes with that, that goes with that, and that goes with that. So if I wrote them in order, we just would have lines like crisscrossing, which is what I normally do, but it's fine. For the purpose of this, I want us to see that every x value is used exactly one time. If it's used more than once, then it's not a function. So this one would be a function because no x values are repeated. I've got 3 points on this one. 9, -2, -3, 5, 9, 1. So input, output. I've got -3 and 9. And then I've got -2, 1, and 5. So I'm actually doing these ones in numerical order. Again, I don't care if you do or don't, as long as you show it. But I've got 9 goes to -2, -3 goes to 5, and then 9 goes to 1. So what you'll notice is that 9 is used twice. Okay, so it's there and it's there. So this is not a function because of the repeated x value. So these questions are specifically asking to say basically is it a function or not. But that's how you would show the work to go with that.
If it's repeating numbers, it doesn't make it a function, right?
Only for x.
Okay.
All right, the next ones are kind of a continuation of this, but they said to decide if it's a function, so they may give it to you, like present the information in different ways, and to tell the domain and range. So the domain is always the input values out of a mapping diagram, range is always the output values, or domain is x, output is y. Again, we don't write any repeats down, so if something's used twice, we don't write it like multiple times, just to be aware of that. So they have these ones, a couple different like ways that they write it. So 20 is still just like these other ones have been being written. So the 0.25, the 0.37, the 0.39, and the 0.511. So as far as this goes, if you want to, just note the fact that you see a 3 as an x value 2 times. That right away can tell you it's not a function. So you can just go ahead and say that. But then they want the domain and range. So domain are x values. I don't write any repeats down. So I would have 2, 3, and 5. And then range is 5, 7, 9, and 11. So that's the y values. Oh, sorry. Typically, if you see more range values or more output values than there are input or domains, that pretty much tells you it's not a function. But just because there are the exact same amount doesn't mean that it's a function either, because if I had a repeated y value and a repeated x value, that doesn't necessarily imply then that it's a function, right? Because something's repeated, I only wrote it down one time. So just be aware of that. But if there's more range values than domain values or more outputs than inputs, then it automatically can't be a function, because that would imply that something's been used more than once. (21) and 22, they present by giving you the mapping diagram, and then you're just determining if it's a function or not, and then stating the domain and range. Domain's this column, range is this column, so I'm not going to do that one again, but they give it to us one other way, and that's with a table. So we've got x and y, and in the x I've got 0, 1, and 2. In the y I've got 0, -1, and -2. So anytime you see something like this, all this is telling you is that this first point is the point 0, 0, the second point is 1, -1, and that last point is 2, -2. So that's just like a FYI. You wouldn't have to actually write that, but based on that, okay, so in a table you might see values being repeated just because of the nature of a table, obviously, if they're lining up. So would this one be a function or not?
Yes.
Yes, it would be. Why?
Because no x terms are repeating themselves, x factors.
Yep. No x values are repeated, so this would be a function. And then what is my domain and range?
Domain is 0, 1, and 2, and the range is 0, -1, -2.
Yep. And that's all you have to do on those ones. The other way that they can present information to you is with a graph, and if we have a graph, at that point we use what we call the vertical line test to determine if it's a function or not. So on number 28, I'm going to draw this as best as I can here. Essentially, that's all that we need. I don't need this side over here. They've given us a graph. All right, so what shape is this? A parabola. So when I am checking to see if this is a function or not, I am dragging. I usually use my pencil. That's actually a little bit wide for us to see it. So I usually drag something across it to look, and I'm looking if at any point there are basically 2 points on top of each other where it means that an x value is used twice. Now, for the sake of this problem, it's a little bit hard to see just because of, my hand drawing here. But with a parabola, it's never going to have 2 x values that are exactly the same. It's always going to be like off by like a little bit for every point. So this one does pass the vertical line test. That means there's nowhere that there are multiple points intersecting my line. So this one would be a function because it passes the vertical line test. So I usually just say VLT for vertical line test. These ones still want the domain and range. So the domain of a parabola, obviously we can only see a little bit of it, but if it kept going, we're looking at what the domain would be, and ultimately a parabola that keeps going, it opens wide, and so it's going to end up covering all real numbers, regardless if it's flipped upside down or right side up. So it's like a fancy R for all real numbers. Or you can write negative infinity to infinity. We can write it like this. I would take it either way that you write it. Now the range are the y values that it takes on. So what does it look like as far as the y values? What does it take on?
4 to negative infinity.
Yep, so 4 all the way down to negative infinity. We always want to make sure we write it in numerical order, so start with the negative infinity when you write it. So negative infinity to 4, and it looks like it's at 4, so we are going to include 4 there. The infinity sides, so up here at infinity or down here at this negative infinity. Infinity is not a specific number, right? Because it just keeps going on forever, so that's always going to be a parentheses, but typically in domain and range, well, for the sake of these, a lot of them are going to end up being brackets because it's going to be like a number that's like a stopping point for it. Let's see, one more of those ones. That's a graph. 30. I've got So what shape do I have here?
Circle.
You sure about that? An oval. These only go to 3. These go to 4. It can't be a circle. So I need to check and see if it passes the vertical line test to be a function. Well, at pretty much every single point, what do you see is happening?
It intersects 2 places.
It's intersecting 2 places. It's intersecting down here and up here. So this would be not a function. The domain would be from, and we're including negative 4 to 4. And then the range would be from negative 3 to 3. On one like that. All right, so pretty much the same instructions, except for now they're giving it to us as like an equation, and we're determining if it's a function or not, and then the domain and range. based on that. So 38 is y equals negative 6x plus 4. Now, what do you know about this equation? Like, as far as if I told you to graph it, what is it going to look like?
Slope.
Yep. It's a line, and it has a slope to it. So, essentially, if I were to graph it, I would have a point up here at 4. My slope is negative 6, so it'd be down 6, right 1. I'm just going to do that. So essentially, I've got a line, something like that. So if I want to find out if it's a function or not, I'm looking to see if it passes the vertical line test. Does it? Yep. So this is a function. What x values does it take on? So what's the domain? All of them. It keeps going on forever. What about the range? What y values does it take on? Yep, also all of them. So the range and the domain of this one are all real numbers. All right, 40x minus y is less than 4. So I would suggest getting y by itself because that obviously makes it the easiest to graph if you do that. So subtract x, so negative y is less than negative x plus 4. Divide by the negative. What happens when I divide by a negative with the inequality?
You flip it.
Yep, so y is greater than x minus 4. So if I went to graph this one, I would have an intercept at negative 4. I would be up 1, right 1, up 1, right 1, so on and so forth. Now, what do we know about a graph like this?
Shade it.
It's shaded. What else do I know about the line? It's dotted because it's just greater than. If it's just less than, it would also be dotted. So I need to make this dotted. And I would be shading, it's greater than, so I would be shading above. So as far as it passing the vertical line test, what do we think? You're right, it does not. Because all these values up in here also make this statement true, so this would not be a function. And it would be a little bit difficult to do a domain and range for this one, so we're not going to do it for that because of the shading. It would get a little dicey, so we're just not going to worry about that. Let's jump to the next stuff. It says to find the following, simplify if necessary. So they say let f of x be negative 3x plus 4 and g of x is negative x squared plus 4x plus 1. So then the problems, they'll give you, say, something like find f of negative 3. So all that means is wherever I have an x in that equation of f of x, I'm putting in negative 3. So this would be negative 3 times, replace x with negative 3, plus 4. Negative 3 times negative 3 would be 9, plus 4 is 13, so the answer to that would be 13. So it's just plugging numbers in, essentially, for the function. If you have, let's do a g of x one. 58. G of negative 1/4. So that means anywhere there's an x in that function for g of x, I'm going to put a negative 1/4. So I have a negative sign, and then my x is a negative, so I want to make sure I put parentheses around this so that it's not confusing. So this negative out here is not being squared. Anything that's in x will be squared. So that's why I also want to make sure I write it like this. Plus 4 times negative 1/4, and then plus 1. So I've replaced all my x's with that negative 1/4. So what's negative 1/4 squared?
Negative 1/16.
So, well, yes. So this negative is being squared, so that would become positive, but ultimately it's getting multiplied by the negative that's out here. So this is going to be negative 1/16. Then I've got 4 times a negative 1/4. What is that going to give me? Negative 1. And then plus 1 out there. So negative 1 and positive 1 cancel each other out. So I'm left with negative 1/16 for my answer. Any questions about those? Are we okay with that kind of stuff? All right, then your problems are 11, 13, 19, 23, 31, 37, 45, 53, and 55. Make sure you have, if there are 2.4 notes posted, make sure you have those for tomorrow. So we'll probably be ready for a quiz Tuesday or Wednesday next week, just for the heads up.